so picking up with number 17, notice there's that word factor completely again. So again, that should kind of catch your attention that you're going to have to do more than one step. And so on 17, we have negative 7y squared minus 12y plus 4. And so the reason this says factor completely is because this first term is negative, okay? And so the very first thing we want to do here is we want to factor out a negative 1 out of each of these terms. So if I factor out a negative 1, which I can just put a negative, it's just like when I factor out a GCF. If I have 3 terms here, I should have 3 terms in here on this first step. And so when I factor out a negative 1, what it does inside here is changes all of the signs of these terms to opposite of what they were. So this will be positive 7y squared plus 12y minus 4. And just like when we do GCF factoring, you have to bring down the GCF, you have to bring down this negative, okay? And so now I bring down my negative 1, my negative that I factored out to begin with, and I focus on this trinomial, and I'm going to factor this. And so 7y squared would factor to 7y times y. And for 4, I can use 4 times 1 or 2 times 2. And again, the last term here is negative, so that's telling me my signs will be different in here when I get done. And so I'm going to try 2 times 2. And so I'm going to multiply outer times outer. 7y times 2 is 14y. Inner times inner. 2 times y is 2y. And remember, this outer product and inner product should give me my middle term, which should give me positive 12y. So I could do that if I make the 14y positive and the 2y negative. That would give me positive 12y as my middle term. And so I'm going to put my plus sign here and my minus sign here. So now, when you put your final answer in here, you have to put this negative out here in front that you first factored out, that negative 1 that you first factored out in the beginning. So all of this would be your final answer. Now, you can also do number 17 with the bottoms up method, but you still have to begin when this first term is negative. You first have to begin by factoring out this negative 1. And so once again, that would give me negative 1 here, make that positive 7y squared inside here, plus 12y inside of here, minus 4. You still have to bring down this negative each time that you factored out. And then you could start your bottoms up method. And that would be to take the 7 down here and multiply it times the 4. And so I've still put my parentheses. 7 times 4 would be 28, so I would have now here y squared plus 12y minus 28. And so then I would bring down my negative here in the front again, and I would focus on this trinomial. And so I would factor it. Y squared would be y times y. Last term is negative, so I know my signs in here are going to be different. And 28, I factor it. 1 times 28, 2 times 14, 4 times 7. So I need the pair of numbers that will subtract, since signs are different, to give me this middle term of 12y, and that would of course be 14 times 2. And I need the higher number to be positive and the lower number to be negative, so that when I subtract them I get a positive 12y. So I will put the 14 here and the 2 here. But now don't forget, with bottoms up, this first number 7, this coefficient here that I took down to the end and multiplied, I have to now put underneath each of these. And so I still bring this negative down here in front that I factored out from the very beginning. I'm bringing it all the way down. And 14 divided by 7 would be 2. This will not divide. 2 sevenths will not divide and will not reduce, so now I bottoms up that. And so this second binomial would be 7y minus 2. And you see that we get the same final answer here as we did up here. Okay, so either way you go about factoring a problem like that is fine. So now we're going to look at number 22. And 22 is a difference between two squares. We are factoring 4 minus 25w squared. If you don't know your perfect squares, then you need to learn them through 12 squared. Like 2 squared is 4, 4 is a perfect square, 3 squared is 9, 9 is a perfect square. You need to know all those through 12 squared equals 144 if you do not know those already. I can see though that this is a difference because it's subtraction between two perfect squares. And so those always factor a particular way. And so I know the square root of 4 is 2, and I know the square root of 25w squared would be 5w. So I know that one of these parentheses is going to be 2 plus 5w times the other one would have to be 2 minus 5w. One has to be plus and the other has to be minus. Okay? So 4 minus 25w squared is the difference between two squares, and that factors to 2 plus 5w times 2 minus 5w. Okay, number 26 on the review is the next one that I'm looking at, and it's 125 minus 8v cubed. And again, now this is a difference between two cubes. Now, if you don't know your perfect cubes through 10 cubed, you need to go back and learn those. What do I mean? Well, 2 cubed is 8, 2 to the third power is 8, 3 cubed is 27, and so forth, all the way to 10 cubed is 1,000. If you don't know those, you need to be familiar with those to help you recognize that this is a difference between two perfect cubes. So whether it's a difference or a sum between two cubes, you still use the same process. And so step 1 is that these always factor to a binomial times a trinomial. And then I use so to put my signs in. So stands for same, opposite, always, positive. And this tells you how to correctly put your signs in your parentheses. So same means same as my problem goes here in this first parentheses. Opposite of that sign, so that would be a plus, goes here. And the last one is always positive. Then in this first parentheses, I put my cube roots. And if you don't know your cube roots, you don't know the cube root of 125 is 5, then use your calculator. But the cube root of 125 is 5. Cube root of 8v cubed would be 2v, because the cube root of 8 is 2. Cube root of v cubed is v. If you don't know the cube root of 8, use your calculator. But the cube root of 8v cubed would be 2v. So the cube roots go in this first parenthesis. Then, to get this trinomial part, I square, multiply together, and I square again. What do I mean? Well, I square this first term I put here, so 5 squared gives me 25 here. I multiply together, so I multiply these two inside of here together. 5 times 2v gives me 10v in the middle, and then I square again. I square the second term here. Well, 2v times 2v would give me 4v squared on the end. And so this would be the final factorization. And so you would work the sum between two cubes using this same process. Okay, so 28. Now we are moving into solving quadratic equations. Okay, and it tells us on 28 to solve for u. And so I have, notice that it doesn't say factor anymore. The directions say solve. And so there's going to be factoring involved, but I'm actually solving and getting the solutions to this equation. And solve for u. And so I first see that it's quadratic. Because of this u squared, I know it's a quadratic equation. Okay? And so I'm going to take and I'm going to factor u squared minus 10u plus 21. And the first thing I really need to check is make sure it's set equal to 0 over here and it's in standard form. you should look at this and read about this on Alex, that this is in standard form. It's set equal to 0, so I'm ready to factor this. And so start with u squared is u times u. Last term is positive, so I know my signs should be the same. They should be the same as whatever my middle term is, so both negative. And then I factor 21. 1 times 21, 3 times 7. And I know that I need the pair that will add, since signs are the same, to give me that middle term. So that would be the 3 and the 7 would give me negative 10. Now notice I still have equal 0. So now I take each of these factors and set each of these individual factors equal to 0 and solve. So u minus 3 equals 0, u minus 7 equals 0. So I take negative 3 over, and it would be positive 3 on that side. I take negative 7 over, it would be positive 7 on that side. So again, this says solve. It didn't just say factor. So when you type your answer in here, you're typing in simply 3, 7 as your two solutions for this equation. Okay, look at number 29 on your review. Solve for W. And notice again that the directions say solve. And so this time we have 5W squared equals negative 17W minus 6. This one is not set equal to 0. And so it's quadratic because I see this W squared. So I know I need it set equal to 0. So that means these two terms have got to come back over here to this left side of the equation. And remember, when you switch sides, switch signs. What do I mean? Well, negative 17W will be positive 17W on this side. Negative 6 will be positive 6 on this side. So 5W squared was already on the left. Bring it down. Plus 17W plus 6 equals 0. Now that I have it in standard form and equal to 0, I'm ready to factor this. So you again have those same two options we've been using for problems like this to factor earlier. You can do guess and check, or you can do bottoms up. Either way, just get it factored. Okay, so if I do guess and check, 5W squared would be 5W times W. Last term is positive, so that tells you my signs should be the same. They should be the same as whatever my middle term is, both positive. And I factor the 6 on the end. 1 times 6 or 2 times 3. I'm going to start with 2 times 3. And if I put the 2 here and the 3 here, then I believe I will have it. So let's check. Outer times outer would be 15W. Inner times inner would be 2W. And that together would give me my 17W that I need in the middle. So this is factored correctly. I'm going to rewrite it here. So this is what we have so far. So now that we have it factored, we set each of these factors equal to 0 and solve. So 5W plus 2 equals 0, W plus 3 equals 0. And so now I'm going to take this positive 2, and it'll be negative 2 on this side. 5W equals negative 2. Divide both sides by 5. So W equals negative 2/5. Solve this one. Positive 3 will be negative 3, so W equals negative 3. So my two answers would be negative 2/5, comma, negative 3. Again, you could go back on this step and factor it using bottoms up, as long as you get it factored so that you can solve and get your two solutions. Okay, so the next problem we're going to look at is 31, and it simply says find all the excluded values for the expression. And so that is find all values for W for which the expression is undefined. That's your key word there. And so we're looking for what value of W could I not have here because it would make this denominator equal to 0. And so the way that we're going to find that out is we're going to actually take the denominator, 2W minus 10, so this is the problem we're given, and we're looking for the excluded values, or in other words, what would make this expression undefined, what values of W. So I'm going to take the denominator, 2w minus 10, and I'm going to say that denominator cannot equal 0, and I'm going to solve that inequality. So I solve it like an equation. Negative 10 would be positive 10 on this side. 2w cannot equal positive 10. I divide both sides by 2, so w cannot equal 5. So my excluded value that w cannot equal would be 5. Okay, on 33, it says to simplify. And so on 33, we have x minus 8 divided by x squared minus 64. And so we must, on these, factor first. Well, I look at my numerator and I can't factor anything there, so that's going to stay x minus 8. X squared minus 64 can be factored. You should recognize that as a difference between two cubes. So that's going to factor to x plus 8 times x minus 8. Now look for matches. What do I mean? Well, x minus 8 on the top here with x minus 8 on the bottom here, that really reduces to 1. And so my final answer would be 1 over x plus 8. And I have now simplified that expression. Okay, so 35, we are multiplying. And on 35, we have 4x minus 20 over 45x minus 40 times 9x minus 8 over 2x minus 10. Again, on these, you must factor everything that can be factored, factor first. Okay? So start here with this numerator 4x minus 20. I see I can factor out a GCF of 4 times x minus 5. Factor the denominator here, 45x minus 40. I can again factor out a 5. So 5 times 9x would give me 45x, minus 5 times 8 would give me 40, times, now 9x minus 8, I can't do any factoring there, so I just bring it down. But the denominator 2x minus 10, I can factor out a GCF of 2. So I factor out a 2, 2 times x would give me 2x, minus 2 times 5 would give me 10. And now I'm looking for my matches. I can cross-reduce this x minus 5 with this x minus 5, so those reduce to 1. And this 9x minus 8 here, and this 9x minus 8 here, I can reduce, those reduce to 1. And then this 2 and this 4, I can cross-reduce, just like normal fractions. So 2 goes into 2 one time, 2 goes into 4 two times. So really, I mark through all of this that's reduced, I'm simply left with 2 times 1, or just 2, divided by 5 on the bottom, or simply 2/5 as my final answer. 37, we are asked to divide. And so on 37, we have 4x minus 20 over 45x minus 40, divided by 2x minus 10 over 9x minus 8. Okay, and I believe we just got through factoring pretty much all of this in the previous problem, but the difference is this is division. And so remember, on dividing fractions, you keep the first fraction, you change this division to multiplication, and you flip, it's the reciprocal of the second fraction. So we're going to do the same thing here with this division problem, but we also are going to have to factor first as we go. So I'm going to factor 4x minus 20. Remember, the GCF is 4 times x minus 5. I'm going to factor out a GCF of 5 here on the denominator, so that'd be 5 times 9x minus 8 again. Change division to multiplication and flip the second one. Now this is only on division problems that you do this. So this 9x minus 8 will now be on the top, and this 2x minus 10, I'm going to factor out a 2 times x minus 5. And so now I can once again do the same thing I did on 35. I can cross reduce. 9x minus 8 and 9x minus 8 reduced to 1. X minus 5 and x minus 5 both reduce to 1. I can reduce the 2 and the 4. 2 goes into 2 one time, 2 goes into 4 two times. So I get again 2/5 as my final answer. Okay, so the last problem we're going to look at on your review is a complex fraction, and it says to simplify this complex fraction. So I have 15s to the 4th over 3t to the 5th u cubed divided by 5rs squared over 9t squared u. This is a complex fraction because I have a fraction as my numerator, and I also have a fraction as my denominator. And I always circle the top fraction and the bottom fraction when I have a complex fraction to help me tell the difference. And so a fraction bar here in the middle of these two really means division. And so this is really another keep, change, flip problem. I keep the top fraction the way that it is. I change this division to multiplication, and I flip this bottom fraction. So this is going to really be 15s to the 4th over 3t to the 5th u cubed times, and I'm going to flip this bottom fraction over. So I'm going to have 9t squared u on the top over 5rs squared on the bottom. Now, I would start with the number part on this one first since there's so many variables involved, and I would cross-reduce the 3 and the 9. 3 goes into 3 one time, 3 goes into 9 three times. Then I would cross-reduce the 5 and the 15. 5 goes into 5 one time, 5 goes into 15 three times. So then I will go ahead and multiply. So 3 times 3 is going to give us 9. S to the 4th times t squared times u is just going to be s to the 4th t squared u. Divided by or over, and then I have on the bottom 1 times 1 is just going to be 1. So I really have t to the 5th u cubed rs squared. Okay, I'm going to put those in alphabetical order. So I'm going to put my r first, then I'm going to put my s squared that's on the bottom, then I'm going to put my t to the 5th, and I'm going to put my u cubed just so they'll line up better. So now I still have some reducing to do. So because this fraction bar, remember, means division, I'm really dividing these. And when I'm dividing powers with the same base, like I am on the s's, the t's, and the u's, then I subtract the exponent. So I'm still going to have 9, and I'm still going to have that r on the bottom, but I need to subtract the exponents on the s's. So 4 minus 2 would give me s to the 2nd, and I know to put it on the top because I had more power to begin with on the top. So I'm going to write that s squared up there. I'm going to put it here. I'm going to subtract the exponents on the t's. 5 minus 2 would give me t to the 3rd, but it's going to go on the bottom because that's where I had more power, so put it here. And this is really understood to be u to the 1st, so when I subtract 3 minus 1, I get u to the 2nd, but it's going to go on the bottom because that's where I had more power to begin with. And so this would be my final simplified answer for number 39.